we started with a problem first, and for us, we built the robots around like the problem we wanted to solve, and like not much more than that. I joke that if if your main toolkit does not contain duct tape and like tie wraps, like you're probably not a fit for us. Like that really needs to be kind of like and that's something you don't need at our stage, right? Maybe your engineer number, 85 needs to. You do need that, right? So it's not that there's no role for them, but I think early on you just don't even know what the problems you're going to encounter. So you need people who are like a mechanical engineer needs to at our company needs to. If there's a thermal problem, they just need to be able to think about this. If it's a vibration problem, they need to be able to think about this. If it's just like a design problem or a manufacturing problem, the three biggest problems, like the three trades that are hardest to find, like in the Netherlands, but I also heard the same in Germany, in the UK, are bricklayers, plumbers, and then electricians. Like that was pretty consistent from almost everyone I talked to. And it's actually a really, really large market. I think people forget about how huge the market is. So just just quick numbers. Like I think the market for bricklaying, so not the cost of the material, but like the actual like labor in the Netherlands where we're operating today is roughly $1 billion a year. I think UK is roughly $4.5 billion a year. Germany is roughly $5 billion a year, right? So these are massive, massive markets. Because of our business model, the thing that I actually like remind our team of every week, every Monday morning, is our product is building a wall. Yeah. That is actually our this thing here is our product. The quality of this, like the quality of that wall, the speed that we lay it with, the cost that it costs us to like build it, or the price that we ask contractors to pay for it. That is ultimately our product. That is what we signed up for. We want to iterate really quickly. We don't want to build the perfect thing. We want to learn as quickly as possible. Having the tools in-house to basically enable the team to try as many things as they can in agri-tech, in construction, and probably in healthcare, I don't know, but like they just have like problems, right? And they need to solve these problems. If you can solve it with technology, that's great. But they don't care about the technology. They just want you to solve the problem. And I think that mindset, is the main thing I would tell people to focus on.
Did robots build the pyramids?
I think no.
All right, Salar, so thanks for joining us. We're here. This is episode 1 of a 4 or 5 part, we'll see how the day goes, a series with you. So in this episode, we're going to discuss the founder story of Monumental. So a little bit about you and your past, how it shaped you, how it led to Monumental, and then we'll touch on some robotics. So how did it all start? Obviously, you built Silk, sold it to Palantir, and now you're here in Amsterdam building some beautiful robots.
Beautiful robots. Yeah, I mean, where to start? I think I've been after. I think like while at Silk, or I think after Silk at least, I have been thinking about like what are like the important problems to work on in life, right? Like what to do next? Like what do you want to spend your time on? It became really like I knew very, very early on like I didn't want to become an investor or like do the like I did want to start another company again. Like that was I didn't need a lot of time to kind of think about that. And then the way I started thinking about this is like, there's this thesis of stagnation. I don't know if you're familiar with it. So like, there's this economist, Tyler Cowen, Peter Thiel talks about this, of stagnation in the physical world. So, there's all these examples in, we used to have the Concorde, right? That's kind of the most visceral example that I know of. Like we used to fly supersonic. You could do like London, New York in like 3.5 hours, I think, and now we cannot. Right, so there's like regression in maybe like transportation, energy, right? Like we had this like upstream of like nuclear, like cheaper, and then suddenly it stopped. And I think the worst example of all of that is like construction, right? Construction infrastructure, maybe. Like you can actually extrapolate like the last century. There's like all these economic indicators. I don't think I need to tell this audience or you guys, but like it's been like it's the industry where we've seen the least like R&D, capex, productivity growth, all these things. I think. I've been thinking about this for like a long time. The real question for me is like, how can I contribute, right? Like that's kind of like, you could be interested in a problem, but like, how do you solve it, right? Like I could also be like, I'm also interested in like solving cancer, but I have no like insight on how to do that. It's, I think slowly while at Palantir and like the years after, I had this insight that maybe my skill set, which is mostly software, like I'm a software person fundamentally, is at a time thanks to like, machine learning, the things we've seen in like autonomous vehicles, maybe I can take those things and apply them to construction or infrastructure, one of those industries, take my software knowledge and build a company solving like a specific problem, but in a way that if it works, you can go bigger and bigger and start to really affect like the way we do things. So that was kind of like, I think, the seed of behind this.
How did you figure out that you want to get involved into tangible company? Because Silk, I guess, that was software business.
Yep. Yeah.
Robotics is just tangible, super tangible. So how did you approach this decision?
Double the difficulty.
Yeah. So like how we actually like tried to do it, or like how I was.
How was your thinking that so because as you said, people stagnate and they do kind of what they always used to do, right? And so for you it was, I guess, software.
Yep.
And now you shifted towards more tangible industry and building robots. So I guess there's part of the software, but also a large part is.
So I mean, there's like I think two parts to this. So like my personal thinking was basically twofold. One is I really think it's important to work on these things, right? It's like ultimately like. I love the internet, I love software, but like we can't eat the internet, we can't live in the internet, right? Like we need things in the physical world. I also thought it was just more enjoyable. Like it's something I actually just was really excited about doing. Like there's something really enjoyable about the work I do, like being surrounded by this, right? Like we just talked about this, like the excitement of just being surrounded by like tangible things. That's both the robots, but also like the things the robots build, right? The built environment, which is actually the fun part of construction in my mind. And the way Sebastian and I, my co-founder, approached this was, I think our mindset is like learn by doing. So I think in many ways we are self-taught, like we've taught ourselves many things. And so before we really started the company, we decided to just like do a deep dive and try to build just together without building a team, or let's try to build some things on our own, like and literally on the level of just getting Arduinos and Raspberry Pis and a 3D printer, and like let's just like, and knowing that we were not going to make something real or professional, but just like it would force us to go through this kind of like learning curve. It shows you the things you don't know, like what are the unknown unknowns we did not think about. And I think we kind of like, this was also like coincided with COVID, so it was a good time to kind of just like take some time, play around with these things, and discover what we didn't know.
So where did you start from in the process of thinking about robotics? Like how does the robotic company like start in your head?
Yeah, was there like a moment you was like, ding, yeah, this is what...
I don't think there was a clear moment. I think there was like a few components here, right? So one aspect that is not robotics related is like I actually started talking and reading a lot with about the industry, right? So one aspect is like where to start. So for me, like one thing, even as an outsider, it's like the let's call it the value chain of construction is actually quite complicated, and it's hard to understand if you're an outsider. So what is the relationship between a real estate developer, a general contractor, all these subcontractors, an architect? There's all these like consulting firms. There are complicated and large money flows, right? Like going on. Who actually makes decisions, right? So one of the things I started thinking about, and I learned a bit at Palantir, is like how to approach enterprise sales. And if you have that mindset and you try to apply it on construction, which I think is a very kind of like productive way to think about like how do you sell into an industry. It's really hard because construction, like any project actually has so many stakeholders. There's no one vertically integrated like entity that does everything, which is really different, I think, from many other industries. So one of the starting points was actually, for me at least, is to start talking to like different people, across, like literally from like maces on the ground to like billionaire real estate developers, and ask them like, what do you do? Like, how does your job, like, how does this industry work? I initially, for example, thought that we might get a lot of leverage from working with, developers, because I was like, that's where the money is. They probably control a lot of things. At some level, that is true, but I think I realized, like, for the things I wanted to do, or like the things we wanted to do, general contractors turned out to be like the right customer for us, at least for this phase. So that was part of the process, to just like understand what things. We went to a lot of construction sites just to see like what do they look like what is. Like on a very like fundamental level, like if you think about logistics, if you want to build a robot that traverses them, like what is that? What does it need to like deal with? We knew it was like a hard kind of like context to deal with compared to like say a factory floor or. So a big part of that was just like trying to learn a lot. And then on the robotics side, again, it's like we looked at like prior art, just like robots, and one of the questions we had is like, why are they so expensive? Why are they so complicated? Can we simplify? What are the parts that are really important in robotics, and what are the parts that aren't? Because on a very fundamental level, what is a robot? It's just a bunch of like joints that need to be moved, right? Like just like you have a motor, an actuator, and just a joint, like it could be steel, could be plastic, like if you just decompose it. So why is it so hard to build a robot? That was just like a very simple question we had in our mind.
It sounds to me like you were very focused on the commercialization at an early stage. You didn't just get obsessed with this like pretty notion of building cool robots and then just sitting in a warehouse somewhere doing nothing.
Yeah. So I do think that's a very fun, like even today, that's a key thing that we're obsessed with, which I think is like one of the reasons a lot of hardware and robotics companies have failed is I think because they attract great technology people. The challenge of being being in love with technology is you could become obsessed with technology, and then you start
your ideas.
Yeah, but you also start building this kind of like beautifully engineered, generic in the sense that it's like usable across like a wide variety of things, unfocused product, which usually means like scope creep, bloat, complexity, and I think that's actually one of the problems with a lot of like say robotics companies or robotic arms is like they're not optimized for a single use case, and that makes them quite expensive because you have to deal with a wide variety of like problems. We started with a problem first, and for us, we built the robots around like the problem we wanted to solve, and not much more than that.
Can you tell us a little bit more about the team and your co-founder, and what's your approach towards assembling the team around you?
Yeah, so I think in many ways my co-founder and I are similar in that we're both software people. Like that, we're not complementary in that dimension. He is a better technologist than I am. Like he's CTO, I'm the CEO. I think I'm more comfortable with things like fundraising, doing these interviews, like those kinds of things. Sebas is, I think, maybe the best software architect thinker that I know in terms of just like, and I think one thing to add there is like I think it's also a bit about for startups specifically, having the intuition of like when to engineer something properly, like do it right, and when to take the shortcuts, right? Like I think that's actually the hardest part of like being good, like a good CTO at a startup. I think for the team, we for the first 10 hires, we bias strongly towards journalists, so like people who aren't just like exceptional in one thing. Did
you hire from construction or?
No, we actually have hired no one from construction. So we did surround ourselves with a lot of people from construction, from the construction industry, so we can learn a lot. We had kind of like partners, customers, like non-paying customers, like early on where we could like talk to them, learn from them, spend time on their construction sites, where we could start deploying when we were ready, like our robots to test things. Like we did make sure we had that environment, but what we needed early on were just like engineers. So out of the first 10 hires, we only had one non-engineer who did everything else, basically. Literally, like we call it like head of operations. It was like everything I needed to happen that was not engineering ended up there. But we needed mechanical engineers, electrical engineers, or mechatronics, like depending on, and software engineers, machine vision, control. So that was like the early team. And one of the things I would add there is like, again, with engineers, it's really easy to find everyone wants to hire the smartest, best people, right? That's obvious. I think for us, we try to stay away from the like academic mindset. You can go very quickly to kind of like the theoretical, let's research things, let's mindset, especially with machine vision or robotics. And that's obviously something you don't want in a startup like ours. So we were looking for people with kind of a hacker mentality, a tinkering mentality, people who get, take shortcuts. I joke that if your main toolkit does not contain duct tape and like tie wraps, like you're probably not a fit for us. Like that really needs to be kind of like and you can kind of like clean up things later, but like just to quickly prove out prototypes, see if things work. I think that's kind of like a key trait we look for, at least for the early like hires.
Do you think that people in construction are slightly biased towards something which was part of the reason why you not hired anyone from construction? Or
you mentioned generalists, right? So I think it was, in my head, that's like you were thinking more broadly to start.
When I say journalist, what I mean is like if you're hiring an engineering team, you can go, you can find people that are really, really good, and all they've done in the last decade is like they're RF engineers that know how to like do what, or like they're battery power management engineers, right? Like they're really, really good at that problem set. And that's something you don't need at our stage, right? Maybe your engineer number, 85 needs to, you do need that, right? So it's not that there's no role for them, but I think early on, you just don't even know what the problems you're going to encounter. So you need people who are, like a mechanical engineer needs to, at our company, needs to if there's a thermal problem, they just need to be able to think about this. If it's a vibration problem, they need to be able to think about this. If it's just like a design problem or a manufacturing problem, like we don't have like, at bigger companies, you could have like really specialized people who just like do only, like they're just like thermals engineer. Like, so that is like what I mean with generalists. One level higher is like we actually have a few people who are like, who are like say mechanical engineers, but they're also comfortable picking up some software, even if you need to. So like there's even some like overlap there.
Yeah, how did you meet how did you and Seb meet?
We actually met like we've been working together for over a decade now. So when I was in college, I was doing this part-time like work at software agencies just because I loved to code. Like that was kind of like I just really wanted to write code and like.
So you have technical background. Yeah.
Yeah. I've been coding since I was like 10 years old.
Oh,
so
nice.
I didn't do computer science, unlike Sebas, who did do computer science. And we met at one of the, like we overlapped briefly. He spent like I think half a year at the company I was at. We met there. I remember being very impressed with his skills, thinking he was like one of the best engineers I knew. And then I think we lost touch for like maybe half a year, like something like that, when he moved on. And then when I decided to drop out of my master's program and start Silk, my previous company, the first person I actually reached out to show like the prototype and the thinking was Sebas. And he basically immediately got involved while he was still in college. And that was basically like the start of that relationship. He joined as like the first employee of that company, or like a first engineering co-founder. And we've basically been working together since.
Yeah, so it's like 10 years, you say?
Yeah, I think even more. I think it's like 13 years, 14 years now. Yeah, crazy.
How long have you been married for?
What's that?
How long have you been married?
Less, yeah. So I actually know Sebastian for longer than my wife. Yes.
Very good. So let's move on to bricklaying. Why did you not start a company which deals with automatic window fitting or pavement?
Yeah, that's a really good question. So I think, maybe zooming out a lot here, basically, like when I started thinking about this, construction, I was actually thinking like really, really broadly. One of the problems that interested me, for example, was infrastructure. Like, why is infrastructure so expensive? Why does it cost literally between 100 million to $1 billion to lay like a mile of track or like of highway roads in most Western countries today? So I killed that direction, for example, very quickly because of the go-to-market. Like, I couldn't figure out a go-to-market that fits an early stage startup, right? Like, the go-to-market is like you have to do huge projects, win tenders, like work with governments. I couldn't figure out something that worked, for example. So that was like really kind of,
Bribery?
Was that?
Bribery?
Bribery? Who knows? So it depends on the country, I guess, or on your market. So, that was like, and then very quickly, I realized that let's say like traditional construction fits a startup really well if you can figure out what to do, because you can do that in many skills, right? So whatever you do, that's not an answer to your question yet, but like whatever you do, you could do it like a tiny shed, you can do a house, you can do a sub-development, you can do a full development, right? You can literally do every scale, which is the kind of scaling you need, I think, for a startup to like go to market. Then why bricklaying? So I think there's like two directions we approach. One is, again, talking to people in the industry. And around that time, when I interviewed general contractors specifically, they all told me, this is like 2020, 2021, everyone told me the three biggest problems, like the three trades that are hardest to find, like in the Netherlands, but I also heard the same in Germany, in the UK, are bricklayers, plumbers, and then electricians. Like that was pretty consistent from almost everyone I talked to. And also, like, just like if you look at like different industry reports, you can find the same data, right? Like it's not like a unique insight. Yeah, yeah. And so, but then like, why not plumbing, right? Like, so it doesn't. I think that with bricklaying, we realized like it's a hard problem, but we did think it's tractable. Like we did think we'd have insights on how to solve it. And the key thing is that we think, if you think about what is it that we're solving, we think there are things you can do beyond that. So there's like a next step, a next step, a next step, that are kind of like of adjacent product lines. And the most obvious one that I think everyone can imagine is you can just do all kinds of other blocks, right? Like you go from bricks to cinder blocks, concrete masonry units, limestone blocks. And you need to change things in your product, like different end effectors, maybe different payloads, different adhesives. But ultimately, like you could see how you could build that. And you could actually see like, oh, we'll take this like, $1 billion market, this $5 billion market. Like there's a pathway towards that with the foundation you lay if you succeed, which was harder for us to see for, say, plumbing or like doing electric wiring or maybe like installing windows or and it's actually a really, really large market. I think people forget about how huge the market is. So just just quick numbers. Like I think the market for bricklaying, so not the cost of the material, but like the actual like labor in the Netherlands where we're operating today is roughly $1 billion a year. I think UK is roughly $4.5 billion a year. Germany is roughly $5 billion a year, right? So these are massive, massive markets just for your first kind of like
product or service.
Product, which I don't know, for example, if that would be the case for installing Windows. It might be, by the way, I don't know, but like that seems slightly smaller to me.
Yeah. So how do you approach product development within what you're doing at Monumental? I've heard through some various people that you're a very product-minded founder.
Yeah,
I
do
think
think
you can say what's the product. Is this a product or is something else is a product?
It's actually a really good question.
That's a great question, yeah.
So because of our business model, the thing that I actually like remind our team of every week, every Monday morning, is our product is building a wall.
Yeah.
That is actually our this thing here is our product. The quality of this, like the quality of that wall, the speed that we lay it with, the cost that it costs us to like build it, or the price that we ask contractors to pay for it. That is ultimately our product. That is what we signed up for, which I think is like both great and terrible, right? Like that's actually the challenge. But I think by framing it that way, it reminds us, I guess, that it's not about the robot. We can take shortcuts with the robot within like reason, right? Like you don't want to have too much technical debt because the goal is to deliver that wall. And sometimes you do that with better software, sometimes it's with better hardware, and sometimes actually just better operations, right? Because we are also like bringing our robot to the site. We're also dealing with a bunch of the site logistics. So that's part of the things we need to get better at or to learn to do well. But that is like our main product.
Also, I think contractors, how can you convince someone that you can deliver that the robot can deliver the work, right? You need to show them really. So that's the outcome is something that you convince people with, right?
And that is a key insight that we've had from day one, right? Like people say construction is this conservative industry, really hard to sell technology into. And I think they're both right and wrong. They are right in that it is hard to sell technology to construction. It's not like they're not like a natural buyer of new technology for many reasons. But because of the model of subcontracting, they're actually very comfortable trying a new subcontractor on a small pilot and then scaling that up if it works. That's kind of a very natural way for almost every GC to work. And so they are willing to take a bet, especially if the parameters make sense for them. If you're like, yeah, I can sell you a wall, I can sell you bricklaying, and I can do it with these parameters, and they make sense to them. And that also is like ties back to your question of like the feedback cycle we have in product development is not, how is this robot performing? At some level, yes, that is part of it, but like the real feedback cycle that I'm obsessed with is we build a brick wall, sometimes in the office, sometimes in at a construction site, and we just like evaluate how it went. We do these things called friction logs where people log, our team logs all the friction the whole day as they're building. It could be literally everything. It could be a bug in the software. It could be an issue with the robot, but it could be just like dealing with cables is like, is a disaster. Any friction that we see, and then we actually just like work through that. We just like continuously improve and take those lessons so that we improve the product.
So you're continuously iterating and
yes.
and like trying to improve the product. Is there like a something that you're particularly aiming for, where you would say like, okay, we've now hit that like perfection or whatever it might be, I mean, and then like we can ignore that as an iterative process.
In the sense that the product would be like finished, is that kind of like the?
I guess so. Or a particular problem that comes up, like you mentioned that you have problems with cables. Say.
Yeah.
Like, at what point do you say that problem's solved, tick in the box, or is that like a continuous as the product? The whole robot evolves.
I actually think that there's like no real answer to this, right? I think that's actually the art of like product management or like doing product at some level. It's like deciding which problems to just like accept and just like we're gonna deal with them for like the next year. That's just like the way it is. Which problems you prioritize because you think they might be existential or they just like will waste a lot of our time. So I don't think there's like a clear cut answer there. And maybe on a macro level, like I think one interesting thing about what we're doing is we can augment everything we do with humans, which is both a blessing because it means, again, instead of like the problem that some robotics companies have is, you need to hit that 100%, but that last percent might be really, really hard. We can try to like get to the 80 or 90% or 95% solution.
Where are you now?
That's a very good question, actually. I think I would say like if you'd asked me maybe 2 months ago, I would have said 85%. Obviously an arbitrary number, but like today I would say maybe like 97%. Like we've made a huge amount of. One thing that a lot of people have asked me is like, when can you do corners? Like if you look behind you,
here we go. Here we go.
We're getting there.
Yeah.
So I think there's like so there are also different ways to like calculate this number. Again, it's a part of this is like arbitrary. But one way to think about this is on an average project we want to take on, how many bricks are addressable to us, right? People think about addressable markets. I think in terms of addressable bricks or square meters. If you would do like this, 17th century like Amsterdam Canal House or a Victorian house with like beautiful arches, lots of ornaments, like the addressable number of bricks would be quite low for us.
Exactly.
But the reality is like we're not building a lot like that anymore, right? And so like for a typical project that we'd look at, I think the number of like addressable bricks or square meters is like getting very close to 100%.
I'm interested to understand sort of like how you throughout your career adopted this product heavy mindset. Was it like something you had to be heavy on in the past, or?
It's honestly a really good question. I don't know. I think it just came naturally to me. Like I've always loved technology, but I've also always loved it for like the use case, like for like having a clear application. I studied physics in college, but I did it because I was kind of like interested in like inventing things, not just. I know some amazing like physicists that are like really trying to like unlock the secrets of the universe, like at that level.
You're not far away.
I love that. I respect that. I totally get that. But I think what drives me is just like I love building a new thing that hasn't been done before. So for me, it's actually like kind of like the other way around oriented from like what could you build in the world that doesn't exist yet.
So what can Pisa 2 do right now? Can they do the whole walls or just inner skin, outer skin, or?
Yeah. So what they can do today is they're made to do like the traditional kind of.
And
like,
I will add to that. Why Pisa? Why do you name them this way?
So naming things. Let me start with this. Naming things. It's like the hardest thing in engineering. I think I think this is true for every company. I think there's like so much time wasted on naming schemes, picking names. So I don't even know if I want to go into like why Pisa. It will bring up lots of company trauma of how we came up with our names. But maybe to like zooming out a bit, like our system today, it consists of 3 types of robots basically. So when we want to build a wall or deploy, we deploy 3 types of robots together. Each of these has a name. That's kind of our current naming scheme. Doesn't really matter. That's not something that matters to our customers or anything. Pisa is the one, I don't know actually if you can see it right now, like if it's in frame, but like Pisa is the one that most people notice because it has the 2 kind of like small cranes that build, that does the bricklaying.
Is it tilted as well?
That's part of the joke. It's a bit tilted, and so it's not fully straight. That is actually like I can expand on why that matters or doesn't matter to us, but like it is part of the joke for us. We have 2 other systems, one that supplies the bricks and one that supplies the mortar, and they work together. And the other systems have different names, and we have obviously more. Out of each, we have multiple systems, so that's why they have numbers. So, what can Pisa do today, or what can the system do today? So, it can supply bricks and mortar for roughly an hour. So that's kind of like the amount of autonomy we're striving for. And then Pisa can grab bricks from the supply system autonomously, and the bricks currently that we optimize for are like the traditional like red clay stone bricks that are very popular in this part of the world, like in the Netherlands, but also in the UK. We can do slight variations of sizes, but like we couldn't do huge blocks today. That's not a huge leap. All we need to change for that is like the end effect of that grip. So you don't need to like redesign the robot. The robot has been designed so that it could do higher payloads, for example, beyond like the payload of a normal brick today. The other part of it is like we have this system that can extrude mortar. We can do it with the same mortar that is used on a construction site, which is quite unique. We basically took on a harder engineering challenge to deal with every type of mortar that exists, instead of saying like there's one type of like custom designed mortar for us, because again we didn't want to change anything in the supply chain of the customers for a bunch of reasons. So, and then work together, and they will lay, put down mortar, and then they will lay the bricks. We can do that for different patterns. So we can do different bond patterns. Basically, I think we can do I would say 99% of the most popular patterns today in the Netherlands, at least, that I know of.
99.
Yeah, because because in reality there's 3 or 4 that are basically the majority of the market.
That's everything.
Yeah, that is actually
everything.
And the cool thing is we actually just a few months ago we were only doing one pattern, and then with software you can see kind of how quickly you can go.
Yeah.
We had the software team implement a few more, and now we actually can do them. What we don't do, let me mention a few things. We have not automated yet. Today, we're still scraping off and pointing the excess mortar. That is something we're actively working today in automating. So that's going to be part of our integrated product. Every 4 to 8 courses, you need to have these tie anchor, anchors ties, that connect
wall
to
ties.
Wall ties, exactly. That connect to the back wall.
And now we're talking about the outer face.
So we're talking about the outer face. That's what we're focusing on today. That's still a manual process. So our robot deals with them. You can put them in, and they will build. Will build over those ties. But we don't install them autonomously or anything like that. We're not sure if we will automate that at all. That's one of the open questions for us. When you go up beyond the height of the robot, we can do that. We use these different scissor lift scaffolding mechanisms. That process is not autonomous yet. So humans will install put down the scaffolds, put the robots up. And the other thing we're working towards right now is corners. So that's the main kind of focus, is to make sure we can do different types of corners. And that's both making the corner, but also driving around this, making sure our autonomous system can drive around corners without human intervention, all of those things.
How many floors can you achieve now?
So with the scaffolding system that we've picked, we can do basically 2 stories with a roof, basically.
Ground
That's
floor,
kind of
first and ground.
Ground floor, first floor. Yeah, so basically we can do up to 8-ish meters, 9 meters of height. Yeah. And that's also again a kind of just market, that's also driven by that. That's the biggest market here. So the next step, to say go to beyond that, it's not that we don't think it's possible. It's obviously you can just go for scaffolds that go, but we don't think it makes sense to focus on that right now from just a focus perspective.
Yeah, one thing I think is important to note is we were being shown around by Lucy earlier, and she showed us how you guys 3D print a lot of the modules within this robot. So that obviously comes into the mindset of how quickly you guys need to iterate. If you have to wait for an external manufacturer to provide you a part to enable a test, it's going to slow you down a lot. So maybe how did you get to that process within the business?
Yeah, so I think one of the things when we started the company that I did this deep dive to learn about hardware companies, robotics companies. It was not fun. Basically, you learn that the vast majority will fail, have failed and it's startups are hard on their own, right? There's all these stats on whatever 10% of startups succeed, but in hardware it's much worse. So it seemed important to me to understand why that was the case if I was going to start a hardware company. And basically the key insight I had here is that most hardware companies end up, a software company, let's say you raise money for 1.5 years or 2 years. The number of iterations, experiments you can run is quite high, right? In many cases, I'd say you're iterating on it twice a month. You're building features on a weekly basis. You're testing them out, maybe releasing them every 2 weeks, getting the customer feedback, whatever. Hardware companies, a lot of them, you talk to them, they're well, we have this design cycle. Our engineers spend 2 months designing something in CAD or electronics. Then it goes to contract manufacturers, some partners. We wait 2-3 months, integrate. You're half a year later now. We have this new we have a prototype and we test it, and then it didn't work. And then you could do this basically 2 or 3 times, and your money it's over. So it was very clear to me that that's not acceptable, and we had to basically figure out how to get out of that. And one way to do that is to basically have an in-house workshop. It's a few things, right? Having the team and the mentality of we want to iterate really quickly. We don't want to build the perfect thing. We want to learn as quickly as possible. Having the tools in-house to basically enable the team to try as many things as they can quickly. That's 3D printers, but even a simple CNC, a machine, lathes, whatever they need. It's always a balance, right? How much to invest in those things versus, and then having the mentality of just let's go as quickly as possible. and iterate. And again, iterating for us is not, let's try to build a robot and see how the robot performs. It's like, let's build a thing and then actually see how does it lay mortar? How does it? So as an example, like when we started the company, the first months, the team that was, team is actually a big word, the 1 or 2 people that were focused on laying mortar, they were not working on robotics. They were literally working on just the end effector and physically moving it across bricks or making simple rigs to see how that performed with just like loose wires connected to some like computer or whatever when we need to automate it. And then only then did we start thinking about how would you integrate this into a robotic arm or robotic system. That was the sequencing. It was not let's like start with robotics here because we knew the hard challenge was actually just like dealing with mortar, not building a thing that moves. Like ultimately that's like a solved problem at some level.
How do you approach iteration in terms of like timescales? Are you thinking, you mentioned earlier that hardware companies can do it like every 2 months, iterate every 2 months. Do you iterate like every day, every week, every 2 days, 3 days? And
I would say our natural company cycle is weekly. So we don't have a lot of meetings.
Can you give an example? What happens in a week, for example, or what happened?
Yeah, so like a typical Monday morning, we have like one company-wide meeting or like one engineering kind of like product meeting on Monday morning. And it's like, what do we need to do basically this week? We have like clear overarching goals, like we need to achieve some big goal at the end of the quarter. And then it's like, how did we do last week? And it's like, well, it could be anything, right? Like we had, in the early days, we had no real projects. So it's like, we're laying mortar, but it's like, we're unable to deal with head joints, right? Like that was a phase we were like, we were laying mortar, but we were unable to do the head joints. Like that's a very hard part, I think, of what we're doing. That's not appreciated. So what do we need to do? And then like, engineers will be like, I think we can try X, Y, and Z. And then we're like, let's focus on X this week. How can we basically like make it as small as possible? What's like the fastest way to like de-risk that idea and like
minimum viable iteration?
Minimum viable iterations. And it's literally like, if it's like, well, I'm thinking of this nozzle that could do this, I'm just making up something. It's like, let's just make that thing. Let's like design that nozzle, 3D print it, glue it on like a aluminum extrusion or like whatever it needs, like tie wrap it, duct tape it. Let's try it physically, see how that works. If it works, like let's see what happens if you like connect it to like an actuator, like step by step. But let's try the hardest thing first, the biggest question mark kind of, and let's try to do that by the end of the week. On Friday, 4 p.m., we have show and tell. Every one of the companies shows what they've worked on that week. It's also a nice way for people to see what everyone has been working on, software team to learn from the hardware team and vice versa. So again, that's like the natural point where people just show off what they've done. And we try to also like, I don't like the kind of let's celebrate failure kind of like mindset, but we really understand that we're running a lot of experiments. So like, if someone's like, I tried this and it really doesn't work, it's fine. And like Monday morning, let's try to figure out the next thing we need to try.
Very nice. I like the process. So you guys just raised a Series A, 25 million. What was the thought behind that amount of money that you guys needed?
I think it's like a multi-step process, right? So there's like an amount of money we went out to raise, which was less than this amount, actually. And then you go into this kind of like, fundraise process, which in our case ended up quite competitive. There was a lot of interest. We had very good dynamics. And so it made sense to raise a bit more. I think there are a few things here. One is, let me mention just like one weird thing about venture capital that that I partly understand, but it's just weird. For Series A specifically, investors just want to take up like a specific chunk of ownership, like a percentage of companies. The range is roughly, I would say, like 15% to 25% or maybe 30% of the
Only
reward.
during Series A?
Yes, for some reason that's mostly the case for Series A. In that I've seen, a wider range of like numbers for seed or pre-seed, and also like Series B and Series C. I've also seen like every possible, but like for Series A, there seems to be this bandwidth for a bunch of reasons, also related to like the bandwidth of like the partnership and how much time they want to spend into a company. So at some point you get into the dynamic where if you can raise a bit more, it makes sense because it doesn't even dilute you more. Mm-hmm. It sort of like on paper increases the company valuation, which should never be someone's, I think, metric. But like the point is like if you can take a bit more money within reason, you should do it, I think. Yeah. I think you should especially do it if you're doing something like us, which is tangible. And I think, what we were thinking about is you have your like plan of like what you want to execute. And then of course, there are these questions of like, we are going into a new market with a new deployment model. and we're building hardware, and there could be so many delays. And I think even the first year and a half or 2 years of the company where we did really, really well, we started seeing, like, it was still kind of like the aftershocks of COVID, where we twice had to redesign things just because of supply chain issues that were happening, like things not, components not even coming in from China, or components not being available when the chip shortage happened. So
That's where you started printing?
no, that's not. We didn't start to print because of that, but it kind of like made us realize, like, this is a complicated beast. You don't fully control your own destiny. You have some dependencies. We try to minimize them, which is again why we do things like 3D print parts. So like a bit of buffer, if you can take it, does make sense. And of course, you can also achieve the next milestone with this money, which potentially will allow you to like raise the next round if you need to raise it later with more revenue, more accomplishments.
Another 25%.
And hopefully less dilution.
What's this money going to help you with? Like, what's your next milestone that you're trying to achieve?
I think so. Our current milestone, like for the team, which is like roughly like the timeline of a year, is we want to go from like the R&D mode and the kind of like early go-to-market experiments, the way I would call them, to a proper deployment model with a fleet of roughly a dozen like systems. That's like the goal that we set out to. So that's everything, right? That's like there's still some like R&D that needs to be done, like all the kind of friction that I talked about, just like working through that, nailing a few key features that need to be nailed, or like getting a few quality control systems right. So that's just like part of that, just like hiring engineers to build those things and having our engineering team execute on that. The second part is manufacturing. So we have, when we raised like that, we had 2 full systems built, like 2. And if you have like built systems or prototypes, we need to go to like more than a dozen if we want to have a dozen deployed, obviously. So just producing more. That's both learning how to produce at a bigger scale, hiring the team to actually assemble, starting to also do maintenance, right? Like we're starting to see that like these things come back. There's right. So building the machine around that, and then finally the actual operational model, because we are. We're saying we're going to basically deliver the wall. We're going to be a subcontractor effectively. We need to actually think about that. That's everything from like hiring and training robot operators that can deal with our robot, can talk to the customer, can drive a van, know how to back up the robot, drive a van, go to the customer side, all those things. So those are like the kind of key pillars of our company that need to happen. And once that we're there, we have like a machine that you can scale. You can be like, yeah, let's go from like 10 to 100, obviously, and let's optimize the performance of each of these robots and start to run this kind of like execution and operational machine. But that is like the current goal for the company.
What's your like key costs within a business, like running Monumental, and how do you approach how you spend the capital you have?
So from like a company-wide like perspective, today the key cost. This is like interesting for every, I think, like tech company, which is like that shows you we're a real tech company, not a company pretending to be a tech company. In the early days, your like R&D costs will dominate everything else you do. Engineers are expensive, especially software engineers, and especially machine vision engineers, or like right, like the more specialized you go, the more kind of like we are doing complicated things. I think one good thing about our team is like people are really attracted by the mission, so we don't need to compete just in terms of money. Like people want to work on what we're doing, but it's still expensive. So if you look at our like where does most of our money go to, it's from the start to today, it's like payroll. Payroll is like for the team.
And tires.
And tires we spend. But that's the thing, right? Like investors come in and they look around our workshop, for example, and they're like, "Wow, this company must be capex, capital intensive."
Yeah.
And I can't tell you right now, like with it, but like there was a point where I'd be like, the CNC we have, like which most people assume is really, really expensive. It's like 8,000 euros. It's like it's not cheap, but it's basically like 3 MacBook Pros. And if you'd walk around like a normal office, like a software startup, and you see like 3 engineers with 3 MacBook Pros, you're not going to be like, wow, that's really capex.
And if they didn't have Mac Pros, you'd be like, what the hell are you using?
Yeah, right. Like, so it's just like, so hardware is actually like, I think one of the wonders of the modern world is hardware is really, really cheap, right? It's actually like, in relative terms, it's like insanely cheap. These tires came from China by truck. And I'm just like amazed that we have like the supply chains in this world where you just like wire money to like China, and then for really cheaply, you just get them a month later, delivered to your office. Like aluminium profiles are really cheap. Actuators are like motors are surprisingly cheap. The most expensive parts of our like on a part by part basis in our robots are actually the electronics, right? Like the cameras we use for computer vision, the switches we use.
It has cameras?
It has a lot of cameras. Yeah.
Where?
I could show you. Like there's
Are the sensors or cameras?
No, actual cameras. So if you look at the gripper, like from where you're sitting, if you look at our end effector, so that's over there, you see like a camera pointing down, for example. But we also the cameras are a bit invisible because we also obviously want to protect them on a construction site from dirt. So they are hard to easily spot, but I can point them out quite easily. Those are like, in relative terms, the most expensive part. Going back maybe to your question, what matters to a company like us is ultimately the unit economics, right? That is actually like...
That's where I was getting.
Yeah. If you're an investor, if you're like, you know the R&D cost in the first years and like during seed, Series A, even Series B will be big. The theory, of course, of every like venture-backed startup is you scale, and at some point those costs will be negligible. The assumption is so kind of profound that most investors won't even look at that cost in your financial model, which again is crazy if you think about the fact that it's the main cost driver initially. But at scale, that's supposed to be like a relatively small cost, whereas what matters is your unit economics. How much does it actually cost to deliver that wall, to deliver like what you're doing?
Can you tell us how much it costs to build something like this?
Yeah, so ballpark cost of our whole system, so that's 3 of these like robots working together, is about 25K, which is exceptionally low. I think we're like, easily like a magnitude lower than like other people have tried to do this before. And again, that is that's because of the approach we've taken. We're not building general purpose robotics. We're also not trying to solve everything with hardware. We're trying to solve many things with software or like machine learning. And that has allowed us to take this approach. And that gives you like very attractive unit economics, payback time on your hardware, like all those things.
How you approach like revenue generation maybe how your thinking about revenue generation has evolved since you started Monumental and now, and are we going to see 5 years from now like robots on sites in every part of the world, or that's different model that you approach?
I mean, I'd love to see that. I think in 5 years, I think we think that when we go international, we will likely focus on like 4 or 5 markets at most. Like we think we could build literally like a multi-billion-dollar company in just a few massive markets. I don't know when or how it would make sense to go like every place in the world, but who knows, right? Like it's always also hard to predict these things.
Revenue generation.
Yeah, in terms of revenue generation, I think, again, what I like about our company is, especially also if I contrast it with my previous company, which was around like data visualization, analytics, it's like, we have such a simple company. Like it's both really complicated what we're doing, and it's like everyone understands what we're doing. We're building brick walls, we're doing bricklaying with robots. Everyone understands this. But also our business model is really simple, because the business model for being a subcontractor in masonry is you get paid by the brick or by the square meter or foot. That I think that's true, at least we know that's true in Germany, the Netherlands, the UK, and the US. Those are I think the markets we understand well. And so you look at our robot, you say it lay a brick, and that's roughly in the Netherlands 80 cents to euro of revenue. That is what it is. If it does that faster, that's faster revenue. If it does that slower, that's slower revenue. In terms of like how, and this, we've kind of like knew this from day one of starting this company. Like when I talked about like talking to these like early kind of potential customers, partners, understanding like the value chain. One thing that surprised me, which is, I guess, obvious if you're from this industry, is I assumed that in the beginning we would need to like not undercut the market in the sense that to compete with it, but just like to, we're a new product. So I thought, we try to understand market pricing, and we're going to go in with like 20% lower to make it attractive for people to try us. And it turns out that doesn't matter to people, and it doesn't make sense for people because of 2 reasons. One is the labor shortage is so severe that any additional capacity, like people want to take it or try it, again, at least in this current market that we're in. So you don't actually need to like compete on price. The other one is because of the cost plus model of construction, which general contractors don't really care. They basically bid to their customers. They have to, like at least here in most cases, they need to like show their cost. They need to show their margin on top of the cost. And so reducing the cost of a component, especially after they bid on a project, doesn't actually make a huge difference to them. And it's not like a very important driver today for, so those are like things that have changed in our thinking since we started this company. But
the outcome as a service for now, and perhaps then shipping millions of robots outside.
Yeah, but we actually still think like, why not own the outcome in the future as well? So it will remain an open question how much we do in-house versus how much we partner with our companies, or like you could come up with all these, like you could have a franchise model, you can lease, like it's hard to predict how that will grow, like especially if we go international at scale. I think people, investors are like they don't like the complexity of a big operational business, but ultimately all the really valuable companies that I know and respect, they ended up having to do it, right? So Amazon started at this like, in e-commerce as this like asset-light software company. Now they literally employ millions of people in their warehouses. They built these very expensive warehouses and distribution centers and data centers. And it's part of building, like if you want to build something really big, sometimes you actually do need to take on the operational complexity. But time will tell what will make sense for us.
Very good. You clearly think different, Salar, so I'm interested. Were there any moments from your past that shaped how you think today and approach your life?
That's a really difficult.
You can go back as early as you like.
Yeah, honestly, I don't know. That's a really difficult question to answer. Like, it's hard to.
Or maybe some tough lessons.
Tough lesson. I do think like I'm maybe less shaped or less influenced. It's something that I've noticed like many times by just like social pressures or just like doing like I'm not. I've never been inclined to like do whatever my peers are doing, whoever my peers are might be, whether it's like just like friends or like. So I think in terms of just like starting a company, there's this category of companies like I'll do X for Y, right? Like it's kind of like a trope. It's like I'll do the the Uber for X, or kind of like that has never been very. Yeah, I don't think that has just never been attractive to me. I like reading a lot of history. I've always liked reading a lot of history. I think in terms of like copying or like analogies, as far as I take any analogies, they're more historical. And I think if you take a more kind of historical perspective, and I don't mean like history as in like whatever, like ancient Greece, although I do enjoy that. It's more like how did technology evolve? Like the history of technology, the history of industry. How did manufacturing evolve? What did like the early 20th century look like? If you look at those types of companies and you take some inspiration of them, like I think the way we build companies today, it's like overfit to like a specific set of constraints, and I'm not sure if they make sense. So I think that opens up like your kind of like solution space and like what could we do. That's maybe one of the reasons I'm more comfortable taking some bets that seem a bit weird for like starting a venture-backed startup today in like 2024.
Maybe last one from me would be an advice for people innovating within the same space as you.
The same space being construction tech? Or
construction tech and maybe within robotics in construction. Doesn't have to be bricklaying, but broadly construction robotics.
Honestly, I don't know. Like, I think the main things I'd say is I do think it's both hard, but I don't know how much harder it is from starting a startup in general. Like, there's something weird about this aspect where every company, I think building any type of company is hard. Building hardware definitely has its like an additional set of challenges. It also makes some things easier, right? Again, like for example, I think attracting talent, like people, you do get an edge in attracting talent versus starting yet another SaaS app, right? So it also makes a few hard things easier. And I would love to see just more founders try to do this kind of thing. And I think my main advice or lesson so far, at least, we haven't made it yet, right? We're still learning, but is this kind of, the way you frame it, like this outcome orientation. That would be my like main advice, is like, don't focus on, I want to build robots or AGVs or whatever the hardware is, or even whatever the software is. Focus on like the real problem that needs to be solved. I think the more you go to like traditional, the untouched industries, the less they care about technology solutions, and they're just like, in agri-tech, in construction, and probably in healthcare, I don't know, but like, they just have like problems, right? And they need to solve these problems. If you can solve it with technology, that's great. but they don't care about the technology. They just want you to solve the problem. And I think that mindset, I think, is the main thing I would tell people to focus on.
Very nice. And finally, you mentioned history. So did robots build the pyramids?
I think no.
Cool. All right, Salar, thanks for that. So that's the end of episode 1. And episode 2 will be going into more deep into robotics, specifically in construction. So thank you.
Thanks, guys.
Thank you. Automation is tricky. You want to have something that is computer controlled and repetitive, and you want to do the job. Construction is, I think, probably one of the hardest because we apply robotics to a site that we might have not seen before.
There's such a big gap in terms of like labor shortages, especially with masonry, where I don't think we are going to take any jobs. There might be a shift, like people who are actually thinking about becoming a mason, maybe becoming a robot operator, but existing masons, we're not going to take
Sounds
their
way
jobs.
cooler.
A lot of our magic actually as a company, where we like bring the real world into the digital world, back to the robot world, and the robot actually lays the bricks back into the real world. Right? You get this full loop actually. And why do we do it? Because the technical drawings or like building information models, like BIM models, are great, but they're theoretical models, right?
They're always wrong.
They're always wrong. We can probably make it faster for you, more predictable for you, and maybe even a little bit cheaper for you. But we need to actually get starting, right? I also understand like your margins are quite low, and you don't want to take big risks. What if you pay me the same amount per brick as the mason, but still have masons on site, right? You have 10 masons there, well, take one mason, put them on another project of yours, speed up that project so you can start the next one even faster, and we'll replace that one on site. If it fails, you don't pay us, and the other 9 masons who are there can still take over our work. If it works, amazing. Next project, we deploy 3 robots instead of 1. They will never buy the machine. They also tell us, like, I will never buy the machine because one, I don't know how to operate it, and even if we make the UX better, right, and all of like the consistency better and everything, like, they probably will never buy the machine because like, as soon as it breaks down, they put it somewhere in the corner of a shed, it gets dusty, and they just do whatever they know because they're already doing it for 20 years, right?
They want the outcome.
They want the outcome, exactly. And as long as we can deliver the outcome, then they're willing to work with us. Then it's on us to make our margin profile better and better, so we actually have a business, right?
By the way, the background noise for people listening is the robot working in the background.
They're mixing a batch of mortar right now.
So always robots driving around here. So
We like it.
There are many sounds in here that you start to recognize at some point.
but keep it simple, and people will work with you.
And you need to just foster goodwill. You need to go on site early in the morning, be there, be part of the team, get your hands dirty, show that you're part of the team, that you're willing to work with them together to get an end result. We're not like the tech bros that come with our fancy toy. No, we're part of the construction team. We're there to deliver value, like Stijn is saying. And I think that just works.
Walk the walk, talk the talk.
Yeah.
Wear the hard hats.
Exactly.
Wear the hard hats, of course.